Hello, everybody. So today we're working with our inequalities. We're going to do a lot of review and then talk about simpler inequalities that build up to more and more complicated inequalities and how to solve those. So starting off, two learning objectives. We can solve simple inequalities, and then I can solve and graph multi-step inequalities. Quick review. So when we're dealing with inequalities, we need to remember how to deal with our equations. We're talking about working with the inverse operations, which just means our opposite operations. So when we're looking at this equation here, 4x is equal to 16, what we need to do first is think what operation is going on. 4x, you see multiplication. So then we need to think what's the inverse, what's the opposite of that operation. We get division. So we're going to divide both sides by what's next to the variable, which is that 4. 4's go away. 16 divided by 4 gets us 4 as our answer. See the operation, do the opposite. That's with equations, but it's also the same thing with inequalities. So that's not going to change much at all. What is going to change, though, is when we multiply or divide by a negative number. When that happens, you need to switch the inequality to face the other way. I'll give you an example. Right now, you got negative 12x is greater than 24. What operation do you see going on? Well, negative 12 times x. So we do the opposite by dividing. When I divide that negative 12 on both sides, it switches that inequality symbol to now become less than. So we have x is less than negative 2. I'll show you why that is. Let's say we didn't switch it around. Let's say it was still x is greater than negative 2. What's a number that's greater than negative 2? Well, you have negative 1, 0, 1, 2, da, 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 da. I'm going to pick one of those easy ones to work with, and I'm going to plug it in. Let's say I had 1, and I plugged 1 in for x. So instead of negative 12 times x, I had negative 12 times 1, because 1 was greater than that negative 2. Negative 12 times 1 is negative 12. Is negative 12 greater than 24? Nah, not even close. Switch that inequality. Makes it true. Negative 12 is less than 24. So with inequalities, if you're multiplying or dividing by a negative number, switch it. Let's get into some examples. We have a lot of examples today, starting with this simple one right here. We got 30 is greater than x minus 3. What operation is going on? You should see subtraction. What's the opposite of that subtraction? Addition. So we're going to add 3 to both sides. Minus 3 plus 3 goes away. 30 plus 3 becomes 33. Now I got 33 is greater than x. Remember, I like my variables first, so I'm going to switch that x around. 33 goes back, and that also changes our inequality symbol. X is less than 33. Let's graph this thing. So on a number line, I would have an open circle at 33. Notice the direction we're pointing here. Think of it like an arrow. We're pointing this thing towards the left. So my graph goes towards the left. Make sense? It's open. We cannot include 33. So we're good to go there. Okay, so now example number 2. We have negative 9x plus 7 is greater than or equal to 25. Solving it just like a two-step equation. I see the negative 9x plus 7. I want to get rid of that plus 7 first. So I do the opposite of plus 7. I subtract it. Subtract it on both sides. 25 minus 7 gets me 18. So now I have negative 9x is greater than or equal to 18. This is multiplication here. So we're going to divide to get rid of it. When I'm dividing, it's dividing by a negative 9, which means I switch that symbol around. Dividing both sides by that negative 9. Negative 9s cancel. 18 divided by negative 9 becomes negative 2. This would be a closed circle going towards the left at negative 2. Example number 3. Combining like terms, getting a little bit more complicated, but I'm looking at this inequality here, thinking of it just like an equation. On one side of my symbol, I have 3x plus 2 minus 2x. I have like terms. Those are terms that contain the same variable raised to the same power. So 3x, negative 2x, like terms. Let's combine those together. 3 minus 2 becomes just 1x, or just x. From here, I could solve rather quickly. Get rid of that plus 2 by doing the opposite. Minus 2. Negative 10 minus 2 gets me negative 12. If I was to graph this one, open circle going towards the left. Example number 4, distributing. So we have those parentheses showing up just like we saw in those equations. We distribute. We take that outside value and multiply it to everything inside. So I have 7 times 2z, 7 times plus 3. 7 times 2z gets me 14z. 7 times 3 gets me 21. So I have 14z plus 21 is greater than 35. From here, solve just like our two-step equations. Get rid of that plus or minus first. So we're going to get rid of plus 21 by doing the opposite, by subtracting. When I do that, I get 35 minus 21, which gets me 14. 14z is greater than 14, so I'm going to divide to get rid of it. Am I dividing by a negative number? No. So I don't have to switch the inequality around since we're dealing with positive values here. So 14 divided by 14 gets me my final answer of 1. If I was to graph this one, it would be an open circle going towards the right. 2 more examples to go. Here's example number 5. Bringing more in. You have distributing and a like term. Let's distribute first. When you see those parentheses, let's take care of those. So we have 4 times that 6, 4 times that negative x. 4 times 6 gets me 24. 4 times negative x, negative 4x. Notice the slight difference in color for the 2 like terms. I have 3x minus 4x. 3 minus 4 gets me negative 1x, or just negative x. Negative x plus 24 is less than 2. Plus 24 we get rid of by subtracting on both sides. 2 minus 24 gets me negative 22. Now here's a weird thing. We got negative 1x, or just negative x, is less than negative 22. That means we have negative 1 times x. Get rid of times by dividing. Negative 22 divided by negative 1 gets me positive 22. Notice the sign. We were dividing by a negative value. Our less than symbol now becomes greater than. One more example to go. What if we got variables on both sides? Same thing as our equations. So I want to move the smaller variable to the other side. I have 8z minus 6 is less than 3z plus 12. So I'm going to subtract that smaller variable, which is the 3z, to the other side. 8z minus 3z becomes 5z. Nothing else changes. Now I solve just like my other two-step inequalities. Get rid of the minus 6 by adding. 12 plus 6 gets me 18. 5z is being multiplied, so get rid of it by dividing. Oh, man. 18 divided by 5. Is that clean? No, it's not. So we're just going to leave it as a decimal. I've got z is less than 3.6. Lot of different type of inequalities here, guys. You had just our simple one step, then we had two step, then it built up. We had combining like terms, distributing and combining like terms, and then of course you have this last one here, variables on both sides. So hopefully we could build towards being able to solve any one variable inequality that we see. Email me if you have any questions. Thanks, guys.